Hi, I got a hand on this ToolTop ET853C scope meter. This is amazing, compact, with rechargeable battery, with built-in oscilloscope, built-in waveform generator, and regular digital multimeter with all these functions like AC/DC voltage, capacitance, frequency and duty cycle, micro milliampere, and continuity tester, resistance and diode test, with tons of features like hold and data storage. Amazing. I'm going to test it quickly and see how we can use this amazing meter to test this amazing scope meter. The model is ET853C. So we have a USB-C probes, proper manual, so we have two oscilloscope probes and the tips and rings for different color, and we have a screwdriver here to adjust and finally the scope. So this is a USB-C connector to charge it. At the top we have two connectors for channel 1, channel 2 here. Let me explain the multimeter. When you turn it on the screen, we have a lot of information, but for simplicity, most of the information is hidden. We see here 4 squares or 4 tab-like buttons, but these buttons are associated to the key below it. So this, we could call it F1. So because I'm pressing F1, as if I'm switching AC to DC, because right now it's in voltage. And whatever you see here, it is related to the voltage. Because we have AC and DC, now this voltage is DC. If you want to change it, AC/DC is written here. We will press this button, and it will change to AC. Or back DC. So any other key that has more than 2 writing or color, then you know, for example, millivolt DC, millivolt AC, milliampere AC DC, microampere AC or DC, ampere AC or DC. And here we have 3. So for each we have to select it. But beside that, here for DC it shows also frequency, and this is just holding the value, the peak, the maximum value that you want to set. So we put it on voltage and pay attention to these terminals. Here we have 4 terminals showing, representing these 4 terminals here, because you have to connect the connectors properly. To not make mistake, this is common, and you will not remove the black from this port ever. The only thing you will change is to move this terminal for voltage, resistance, and capacitance, and everything else, and for milliampere, microampere, or full up to 10 ampere. So you move this red. And also it shows which terminal is supposed to be connected. So these 2 terminals on the right side are used here. These 2 are shown here. Now if I go to microampere, immediately you see that this has changed. Now we are in microampere, and the same way you see came back. And then if I go to ampere, 10 ampere, it moved to the left. So meaning I will connect it between common and the last port, like that. So this visual representation also will help you. To turn on this flashlight, we press the menu and hold it for more than a second. And for more than 2-3 seconds, it will turn it off. These two terminals are for oscilloscope, and the middle terminal is the function generator. You can charge it from this port here. When you connect the charge, it will be red. Once it's fully charged, this light will turn green. Right now it is fully charged, and the battery status is shown here. Multimeter is sold on Banggood. I'll provide you the link with a coupon so you can save. At the moment, the price is about $77 with $4 shippings. When you use the meter for any purpose, it tells you the connectivity. For example, right now we are measuring the voltage. It says these two terminals to be connected. Now if I go to millivolt, that's the same. As soon as I go to current, it says go here because we are at the microampere. So this positive should be connected in here. Now if I go milliampere, it's the same. But if I go 10 ampere, it says connected to this last one. So this is how we connect. Now to start using it, let's connect our probe. To measure the voltage, you put the selector into V. Now we see volt, and here I have a voltage source. I'm going to connect. I'm going to change it. This is amazing. Let's go high. So 7.56. And the range at the moment is 20 because it's auto. Resistor. .128 ohm. $993 kilo ohm. Measure DC current, we rotate this and put it in ampere. Now this is when you go for 10 ampere. So the common stays here. Remove this, put it in here. Now you cannot connect it directly to the battery or anything. If you connect it directly, there is a 10 ampere fuse, it will blow out. So to measure it, we will put the load in series. The positive is here. It goes to the load. Let's say this is a motor or resistor or anything. Put the negative to the negative of your power. Now we have one positive left. So the negative comes, passes through, and it is in series. When I connect it, here it shows the current 1.86 ampere for this resistor. If you don't want a fluctuation, you can change the range from auto to, so right now it's auto. I'm pressing this auto range. Now it says 20 and then 2. So it has two values, 20. Now it goes to 20 amp range, 1.87. Now to save the measurement, press save and hold it. Now the save appeared and it is saved. To view the saved data, press menu, and then this menu, go to data. If it is up and down, go to data, press OK, and here we can see 1.86 ampere. This is 993 ohm. I can press this and save it. So this is 993 ohm, and let's measure the current. Because I know it's milliampere, I'm gonna go here. By Ohm's law, I is equal V over R. I'm gonna go with about 3 volts. We are going to measure it. So 3 divided by 993. So this will be 3.1 milliampere. About 3 milliampere. So let's measure the voltage first. This is my power source. Save 3.12. So 3.12 divided by 993. So this is 3.14 milliampere. Let's see. So how we measure? We measure it in series. This is my power. Connect the positive to one terminal of the load. This resistor is our load, and negative to the negative of the terminal. Negative from the battery or power to the multimeter. Now the negative is coming from this side. Let's put this to milliampere and rotate this to milliampere and connect it. So 3.11, I can save it. It has been saved. This is amazing. I connected this back to, now I have another resistor. Let's measure it. 1.49. 1.49. Let's save it. $1.52. It was fluctuating. So let's measure the microampere. So divided by 1,500,000. 0.2 micro. That's 100 milli, 10 milli, 1 milli, 100 micro, 10 micro, 1 micro, 2.08 microampere. Let's go to the microampere. Positive to the terminal, negative. Positive to the resistor, negative to the terminal, and here we have to make sure that this is connected to milliampere as it says here, and let's measure it. 2.1, 2.09 or 2. Yeah, safe. Amazing. menu, and then menu, data, okay. So we can see our data here. Now let's measure AC. To measure AC voltage, we will turn it on. I'm measuring the AC voltage on the outlet. Right now it shows DC. Press this key. It turns AC and it is in auto. And it shows 116.79. If you want to save it, just press save. It is saved. To measure the frequency, press this, rotate it to hertz. The frequency of AC line, 59.98 hertz. Now to get the duty cycle, press this. Now it will give you 49.96, so that's 50% of the period. Let's measure capacitance. We set this into Cx, and I'm setting it to, I'm using this 3.3 microfarad capacitor, the positive to the positive, and the negative. And when you connect it, then wait until the capacitor is charged. .15. Make sure do not touch the other pin. .6 nanofarad. Now to measure diode or transistor, we set it at this point. To test a regular diode, cathode is here. We have a line. Put the positive on anode and negative to cathode. And this is 0.6 volts. If you reverse it, you should not read anything. The diode is okay. The same can be true for the small signal diode. And from this side it shows. To test a transistor, this is 2N2222. The base is in here. We put the positive at the base, and this is base, the middle one, this is collector, and the left side is emitter. Diode and continuity, and select F2. Now we are in diode mode. It says diode. Put the positive to the middle terminal and negative to the right side. And read. Remember the number, this is 700, 0.700. And emitter should be a little higher number, just barely. And if I go in reverse, I should not read anything. So this turn on the function generator, press menu. When you press the menu, let's go to AWG, this key, F4. And the type of signal that we see is square wave. It shows square, and the wave is selected by this button. When you press it, it becomes ramp, and it becomes sine, and returns. So we have three types of wave, but for each we have all these settings. We have frequency, amplitude, and duty cycle. When I press this, you see all these preset values are available up to 5 megahertz, and it goes here up to 500 hertz from that side. So it's 1 kilohertz. If you want to just change it, go up and down, select and press OK. Now the value has changed. It shows 5 kilohertz. The duty cycle shows 50%, so it means 50% high, 50% low. If I change it, let's say make it 30%. On the screen you don't see anything, but it shows 30%. The wave shape is just an example. So Let me go back to scope. Now this is a square wave, 30%, 5 kilohertz. Menu, oscilloscope, OSC. Now this is oscilloscope. I've connected it to channel 1, and the signal now shows here out square wave. So this is very important that we know what type of signal we have. You don't need anything else. If you want to measure it with this scope, you just need to connect the tip. So we have to either bring it down, shift channel 1 because we have connected it to channel 1. You can either adjust it manually to see the signal or just press auto. It adjusts and shows you the signal. Our signal is like that, and we can zoom in or change the time. Right now it's 50 microseconds if you want to see it properly. And the wave shape, if the wave shape is not correct, also we can adjust it. Now let's change the timing. I'm pressing this button, and as you can see, it shows now in terms of time. Let's select time. Right now it's 50 microseconds. Pay attention, now it became 30. We see more of the wave. And if you want to see less, like that. Now this is a position of time. You can move the signal left or right to see certain position. If I press this again, it comes back to time. Excuse me. So now it's 2 volts each square. Each square vertically has a value of 2. Now let's say you want to measure here the voltage. Now let's change the signal back to sine wave. Press menu, AWG, and press wave. Come back, go to oscilloscope, and you see the signal is indeed sine wave. For conclusion, I would say that this is the best deal that you could get with about $80. Compact, easy to use, built-in oscilloscope, and also a basic function generator with very precise measurement and all the tools at your disposal. It's really worth it, and I paid, like for some of my multimeters, I paid over $200. Believe me, this is much better, especially the rechargeable battery, easy to charge. I have very expensive multimeter, and I hated to replace the battery from time to time. Also, the screen is old LCD. This is now all color. The buttons are easily accessible. It can save the values. You can recall it. Like 2,000 records can be recorded. You can save the waveform. You can save also the oscilloscope. The measurement is up to microampere or microvolts. This is amazing, unbelievable. Definitely recommend this.